From the previous theorem, it's clear that the set of integers can be divided into m different sets, which is called congruence classes modulo m, and each containing integers that are mutually congruent modulo m. So the meaning is, if you just try to divide any given integer by m, then there is a remainder, and remainder should be between 0 and m, so including 0, not including m. So you can regroup whole integers into m different subsets by that each subset is collecting of integers having same remainder after divided by m. And if you just choose any of these subsets, all the elements in there is mutually congruent by each of them is mutually congruent modulo m. That's the meaning of this definition. Okay, next one is, let's say m is a positive integer, and for given any integer a, by the division algorithm, we have that a can be written by b times m plus r, and r is between 0 and actually less than m, so it should be less than or equal to m minus 1. Then we call this r, the remainder, is the least non-negative residue of a modulo m. It's just terminology. We can just simply say it's a remainder after divided by m. And this r is the result of reducing a modulo m. There are several ways to say it, okay, like that. Okay, next definition is the division algorithm shows that the set of integers from 0 to m minus 1 is a complete system of residues modulo m, which means the complete system of remainders after divided by m. So this is called the set of least non-negative residues modulo m, or the meaning is the set of kind of non-negative remainders by divided by m. Okay. And the next definition is a complete system of residues m is a set of integers such that every integer is congruent modulo m to exactly one integer of the set. So the simplest form of this complete system of residues m is 0 to m minus 1. Right? We have full set of remainders, but instead of 0, you can put m in that set. So from 1 to m, that's another full set of remainders. Of course, we cannot say it's a remainder, because in our concept, remainder should always be between 0 and m, right? Including 0, not including m. But if you accept that as a residue after divided by m, then it depends. So if you have one less quotient when you divide given integer by m, then your remainder becomes certain number, which could be greater than m or less than 0. So if you don't care about that condition for remainder r, then we can make this complete system of residues m with certain integers which are kind of representative of each remainders, right? And one thing is clear, to become a complete system of residues modulo m, it should contains only m integers, because it should be same as 0 to m minus 1. Right? Okay, so these are the collection of definitions for this section.